Good morning, everybody.
Morning, Raj. How you doing?
Morning. Yeah, I'm doing all right. How are you, sir?
Oh, pretty good.
Very
I
good.
just tried to look at the API draft and or the specification draft and I got it denied. So if you have access
Oh,
to share that with me, please do.
you got denied?
Yeah.
The audacity. Oh my goodness gracious. Let me fix that ASAP, sir.
It's a Google Doc. Oh.
I know it's a Google Doc. Yeah, funny as hell. Okay, let me see. Yes, manage sharing, review, share. Oh, actually, you know what? Let me editor share sharing. Okay, you should have an access to it now. Morning, Stephen. Morning, Tim.
Howdy.
How are you doing?
Run from meeting to meeting.
Good morning. Or afternoon in my case.
Yes, afternoon. Sorry. Yes.
No,
Forgetting
it's
you're in
okay.
Boston. Morning, Philip. Morning, Srini iPhone.
Hey, good afternoon, good morning.
Did you change your last name to iPhone?
Not sure it is coming from my phone. I joined today from there. Uh,
Just kidding, man. Okay. All right. So, Alicia, not Alicia. Oh my goodness. Allison is not going to be joining, not going to be able to join the meeting today. As far as Dong is concerned, I'm not, Dong and Jean-Marie are concerned. I'm not sure about them. Sammy also may not be able to join because he apparently is in India and he hasn't come back yet. So, but we have a lot to cover today. Um, by view, by way of updates. Oh, let me first start with opens from anybody today. Any opens? Anybody? Questions? Rants? Comments? Okay, I'll take that as a positive.
Hey, just one question, Raj, Stephen.
Yes, sir. Yeah.
As most people may be aware, next week is the OCP regional event in Taiwan.
Mhm.
I don't know that. I think I would be aware if we submitted something. But are there any OPF sessions that were accepted for that event? Do we know?
Not that I know of. I know
Uh-huh.
that I did get an email from was it from either Neil or from MyTag, either ByteDance or MyTag, and they asked me if they could present the OPF update, and I said, yeah, by all means, absolutely, you should. And but that was that would have been for the OpenSFI and UPCI, but I didn't hear from him after that. I would have expected him to get a presentation slide and review it here, but apparently,
Yeah,
yeah,
just curious. I guess it's all posted now anyway. I
right.
could take a look. I just didn't know offhand.
Right. No, I mean, other than that, I don't have any communication, unless Jean-Marie or Dong or Sammy has been involved in that. But if they were involved, then they would have definitely added me into those communications. But probably looks like there isn't any, other than that one comms that I got from from my tag.
Yeah.
Okay. All right. So let's start with some updates from an AMD side. I was hoping that Bert would be here today. I tried to get him in, but he appears to be offline. So OpenCell, we are, like we mentioned, we are planning to make a contribution of the 1.0 spec to the OCP, and that is making some good progress. We've signed the CLA and whatnot, or at least Bert has, and we'll be in front of the steering committee in August 23rd, I believe. Let me see. This would be on August 21st, 8 a.m. Pacific. Okay, so there's a 15-minute presentation that we're going to make to the steering committee. And it's the same presentation that we did for OpenSil many moons ago. And that is what is going to be presented to the steering committee. And we can also bring that in second week of August here, and make sure that everybody is aware of the content that is going to be presented. And if there are any feedback that you guys would want us to take, incorporate into the slides, we'd be more than happy to. And we'd be very appreciative if there is any feedback, of course. And so once that is incorporated, we'll update the final copy and present it on the 21st at 8 a.m. I also would, I'm hoping that, on the side, I will also send a copy to Dong as a pre-read for him, because he represents us in the steering committee. And so hoping that it will be a smooth sail and we'd be able to finalize the contribution end of August, and we can make an announcement in one of the sessions, one of the presentations, or even right at the beginning, during the global summit session, when we open up the OPF sessions, we can make a mention there. And so that was an update from my side. So that is what the plan is currently. Um, on the OpenSFI, I started to pull together the presentation. It's not complete yet. Let me see if I can even share it with you guys here real quick. I mean, it's still work in progress, so don't be judgmental, please. Um, Let me see where it is. And that presentation, by the way, is in the OPF project. So let me first, how do I share? Share, there you are. Share my desktop. Okay, and Google Drive. Okay. OCP collateral, 5G. Here's the one. Can you guys see my screen?
Sure.
Yes.
Okay. So it starts with the prompt statement recap, and then the solution recap, and then moves on to what the status is. The vision mission statements have been documented, and I'm expecting that Stephen, what you have been after hasn't been completed yet. But I'm hoping that by the time we present it, it will be there. So I'm hoping Sammy will resume this work. He'd be able to get back sooner than later. And then the requirements, they have been documented. I did put the requirements in there. These, by the way, these requirements are AI generated requirements based on the 0.3 spec. And yeah, I know it is back words here, but we should have started with the requirements, documenting the requirements, and then move to the specification. But it turned out the other way around. But anyways, requirements, and then the version 0.3 specification ratified and ready for release. By the time I'm hoping we get to the OCP summit, it will be released a day earlier or on that day, and then we'll post a link of this for the spec. The API is defined and alignment on input arguments. So that would be something that the UPCI folks, Felix, you and Tim, you will be presenting in the UPCI presentation. There, I'm hoping that you will make a statement that OpenSFI will be adopting XYZ solution identified for them, right? So I didn't want to mention it here because that is your news, and rightfully. And then I go on to talk about the API, initialized silicon API, followed by the execute silicon runtime op API. And then I will also talk about the roadmap timeline here of the 0.3, 0.5, 0.8, and finally 1.0. So like I said, it's not complete, it's a work in progress. And then finally, a partnership acknowledgement of who all are working on this. And then I haven't done anything on the call into action. That should be pretty much it. That's a general format. Any feedback so far? If not, that's fine here, but the presentation is in the OPF folder. So feel free to access it and make comments live in the document. All right. Okay. So as you know, you guys, I do try to keep you guys. Where is it? I do try to keep you guys updated at all times, even with the 0.3 spec. I think it is in a good shape. There was excellent feedback that came from Jose Marino from ARM, and it did make me scratch my head a little a little. And so based on that, I did respond to him in the document. But at the same time, I thought, gee, it would be great to put that clarification so that those type of questions don't arise again. So I put some clarifications in the documentation. Hopefully, it is to Jose's satisfaction. I'm not sure if he's attending today, but now how do I go back? There you are. Is Jose here? No, Jose is not here. Okay. Hey, Giri, thanks for joining.
Hey, Raj. Okay.
And this would be probably Jeff, right?
Hey.
Hey, Jeff, thanks for joining. Okay, so yeah, with the feedback, I think the document is taking a really good shape. And I definitely am very excited. Now, the next few things that are in my mind is the 0.5 version. Now 0.3 will allow us to start the development. Now, what does the development really mean at this point? The development is of the val library. Val is your vendor abstraction layer. It's basically an implementation of the specification. So, but without some key elements being defined, one cannot really start that development. So what we really need is right after 0.3, or maybe even now, if somebody can take a stab, or somebody needs to take a stab, both from AMD and from Intel, for both the x86 vendors, is to define the stages. That is super important for us to get the ball rolling on the library implementation. And somebody also, correct me if I'm wrong, but the intention for the val is for it to be a library. So the val library will be consuming the OpenSil / Intel FSP, and by consuming meaning it will be calling into the OpenSil / Intel FSP. And both Intel and AMD will have their own val libraries, so that the platform manufacturer can um, can use their choice of whatever the host firmware is, and that host firmware will be now able to call into these library functions, these val library functions, OpenSFI val functions. Um, and whether, depending on the platform, they could be using a val library written for Intel or val library written for AMD. So it should be as straightforward as that. Am I making sense to everybody? I'm particularly looking for feedback from Microsoft and Google. I mean, yes, firmware vendors too, but I want to make sure that we are all in alignment.
So, Raj, yeah, fully aligned on where we want, right? But the questions more are like clarifications we may need to do as we go, right? Is more on the details. For example, the very high level architectural difference between AMD and Intel, right? AMD does before host firmware runs the memory initialization versus post. So thinking of that, right? How do we see that? Because in some cases, we can use that as a feature, right? Hey, we don't need to do this versus do that. And without getting into like feature level and all, how do we think of these stages? And I know we want to be non-EDK tied to that or agnostic to that, or framework agnostic. But that means, I think looking at that, right, the phases, or we call it stages or numbering, whatever we want to, that's where I'm still not like fully visualizing how it would look like. But those are more on the details side.
Yeah, that is in the details. And I think based on Jose Marino's comments, I'm not sure if at what point in time you joined the meeting, but he made some pretty good comments, which made me add some clarifications into.
Yeah, I didn't check on that yet. So yeah, I'll check.
Go ahead and check that. But yeah, here's the idea. The idea is that we have a header file that has an enumerated list of, which would be a superset of all the stages, silicon initialization stages, right? Common to everybody. And it's a superset, not common, but it's a superset that covers both the x86 vendors to begin with, right? And so now, for example, it will have memory initialization, right? Memory in it, right? That could be one input init stage.
Yeah.
Right? Now, would it be applicable to AMD? if the answer is no, when we get if and when we, meaning AMD gets that initialized silicon init memory API, we will simply return back saying unsupported or simply saying done. Right? Complete.
Got it. Yeah, that's what I anticipate. Or even like there still need to be some things like translating, like in an ADK2 side, you need to publish some resource information and all for
Yes.
rest of the host
Yes.
firmware to consume.
That
So
is it.
yes, it doesn't need to be initialize. It could be just translating the
That
data
is
to
correct.
read. Yeah.
Yes, yes, yes. So that's why I said, okay, done with the pointer to the output buffer
Got it.
was pointed, passed as an argument. So we will, the OpenSFI would be responsible to fill that output buffer and pass it back to the caller, right? So that would be a contract established between the silicon vendor and the host firmware. As simple as that.
So Raj, there were still some other clarifications on that. On that was who owns the output data? Is the caller own the output data, or the callee own the output data?
The caller owns the space allocation for the output data.
So how does the caller know how much space to allocate for that then?
Yeah, brilliant solution. I mean, brilliant question. So this would be published in the header files. So
the header file is going to say that I allocate 50 kilobytes for the output. Does it define or what?
Yeah, so we will have the prototypes and the structures published in the header files, right? And those header files will be consumed by the host firmware, right? So they will know, looking at that output structure meant for either. So there would be this the structure that would be defined. Maybe it may be common to both AMD and Intel. If it is not common, I'm assuming that we would have these header files that are specific to the vendors, right? So one would be for Intel, and a similar one would be available for the for AMD. And so depending on which silicon we are building the firmware for, right, or which platform we are building it for, we will use the appropriate header files.
So let's dig into that a little bit. If I have a variable length data structure like SM BIOS records, how do I know how much memory that the caller should allocate for things like SM BIOS type records?
That's a brilliant question.
Yeah. So I think we need to look at that, because even though I have the pointer there, the function is going to have to provide some data back. Some of that may be variable length, and in fact may be dynamically created during the execution of the function, in order to, for example, how many DIMMs, what the contents of the DIMMs are, if they're present or not. There might be variable stuff there. So identifying who owns the memory and whether the caller is able to free or not able to free the memory that is passed back is something that I think we need to spend a little time on.
Got it.
So agree, Tim. That one, just one point to that, right? Definitely, I think that's what will be a challenge, right? Is do you query even the size required before you even allocate, or we stick with here is the max, like using the same example as SM BIOS, right? It's a variable, but the spec defines max as 256 bytes. So should we always allocate 256 and read it? So it could be based on API, because the memory brings up the whole question, right? Based on how many DIMMs are populated, we may need that much info to be expected back. So how do we calculate those things?
Right. Yeah, those kind of things. Or even the example of ACPI tables being returned, right? ACPI tables are also variable length.
Can we possibly assume a max length or something of that sort?
It will be difficult, Raj, based on silicon architectures or platform configurations and other things. So Because it's all a multiplier, right? Of X number of PCI devices or X number of DIMMs or certain things. So even SM bias, for example, right? It's how many tables you expect.
Or number,
But
it might be based on number of cores populated in the system, right?
Number of sockets, we
Right.
can think of some ways, but it's going to be challenging to have initially, right? To have a set. We need to start with something and then refine it.
so in OpenSil, the way we've done is that we first query, hey, how much space do you need, right? What is your requirement? And then the silicon initialization comes back and says, hey, this is how much you will need.
Raj,
Which
one
goes-
question.
Yeah.
Are we planning to return the actual structure, or is only we're returning the metadata?
Now we are returning the pointer to the memory space, right? That would be supplied by the host firmware, right? It would be the OpenSFI's responsibility to fill up that space with the information requested.
No, yeah, understood. It will be filled up. Will it fill up actual SMBS data or just the metadata?
Oh, metadata, of course, not.
So yeah, that in that case, I'm thinking whether that it will be fixed. See, what example that we are talking about is ACPA or SMBIAS structure. Those can be variable length. But if you are only talking about metadata that somebody can consume and fill the structure later, there are cases it can be fixed length. Before that, if you are only passing the metadata.
I
Right.
think
Yeah,
I'm not sure I'm following you there, Srini. If I'm taking and I have to fill out, let's say, an ACPI SRAT table, and I have to identify how many cores in order to know what the size of the data that's being returned, there might be 256 cores on this machine, or there might be 128. I don't know until I make a call and ask OpenSFI what the requirements are, what actual capabilities of the platform are.
So I'll ask the question again. I mean, is assuming a max not a possibility to keep it simple?
So again, the max some of this has to do with whether we assume any binary caller is going to be able to call into this interface, or only people who have access to the exact source code of the final implementation. For example, if I have an OpenSFI header file, the OpenSFI header file, is that tied directly to the piece of silicon I'm supporting, or is that an abstraction? Is it a level above the actual silicon that I'm actually dealing with?
Well, at some point in time, there was a comment from Giri, right? At some point in time, this abstraction layer kind of squishes, right? And this abstraction layer gets natively adopted into Intel FSP and OpenSil, right?
Right.
So the intention is that it be, that is in relation to the silicon initialization, and not just the OpenSFI layer itself.
Right, but when I write my code for OpenSFI, I probably only want to include a single header file, not one file that's OpenSFI and one file that's silicon specific in order to build.
No. You're right. You're absolutely right. It has to be one file that is OpenSFI.
Yeah.
One file for silicon in it and one file for OpenSFI. No, I agree. It needs to be simple, not complex.
So I think we need to look at this idea of who allocates the memory and how we specify that. So going back to our previous set of discussions, Raj, about the supported layer, the supported call, maybe one of the outputs of the supported call that might be what is the expected output size or expected amount of memory needed to hold the output data.
Can we assume that whenever the output data, the pointer to the output data is passed, can we assume there is a large amount of space available already? Like, let's say 10 megabytes.
You want to assume that on Intel platforms? I don't think that that's necessarily.
So Raj, the challenge would be right on AMD OpenSil, because the memory is pre-initialized. We have some freedom there, but with Intel, right? The memory you need before that we're running in cache as RAM, which is purely silicon dependent, right?
Yeah, but 10 megabytes, even for caches? How much are the caches?
I don't know, right? It's per
How much caches do we have anyways? I mean, I'm just asking. Is 10 megabytes an outlandish number?
I'm
Yes.
saying that how much can we expect to give just to the OpenSSL interface, OpenSFI interface is a question, because that RAM is also used by many
for
other
code
things.
and partitioning.
Yeah, then we have to basically partition the memory off and say, okay, all of this, but all the other pre-RAM code can't use any of that memory because it's reserved for potentially use by OpenSFI. So
Okay, so at this time of the boot, you are not doing anything else, right? So whatever the memory that you have, whether in caches RAM, whether in DDR or whatever, you assume that the maximum amount is allocated for the output buffer. Everything is allocated for the output buffer. Now, the question is, would the silicon initialization ever come back to the caller saying, hey, the amount that you allocated, I cannot do it in that amount. I'm giving you maximum in the platform. So what does that tell you? That tells you that there is not enough memory to begin with.
well, for example, the stack is also in the same space, right?
Minus the stack.
Right, but the stack could, with a debugger, stack can also grow. I'm pointing out that you're asking an unknowable question.
Yeah. So what is the max that the stack can grow, right? During the operation, during that particular operation, there's only so much, right?
Yeah. Well, if I get an exception during the middle of it, then my exception handler has to have enough to put all the exception state onto the stack. But yeah, you're right. I mean, there's a theoretical limit, right? When we decide to allocate how much stack space for a pre-RAM, we do have to kind of guesstimate how much space that is, and we have to guesstimate how much space everybody else needs for RAM. So I don't know that silicon initialization is the place where we want to be guesstimating that. And the answer, I think that we'd like to be able to get a more definite, be able to know ahead of time what a definite, at least a ballpark.
But just out of curiosity, so from a cache's RAM perspective, how much cache of RAM do we initialize?
So I can say like it's definitely not in the 10 meg range that we allocate, but yeah, there is a range, but also that's used for caching the image itself also, Raj, along with data for stack allocation and for simplifying, right? This is all like partition. Okay, let me take this whole chunk, right? It's not precisely fine-tuned and for a reason, right? Just like you described, is we can't just go to the fine details and leave some room for other things. And on top of that, there are multiple buffers that we may need to populate the input and expect output, right? So we also need to consider that. So this is all like, I would say more silicon specific. That's where Tim's questions is what echoing with me also is, right? How do we predict and predict the future, not just today, right? Maybe there will be a version which has less RAM for like lower skew or another thing, which may have higher. We always go with the lowest denomination, right? If there is a variance, so that we can support with this unified model rather than, hey, this one has like higher and we can use everything. So there is always a trade-off, but I think instead, I do like what Tim was suggesting earlier, right? Is can this be queried as a simple API? Here's what I need, so that that's not like something we always stay with this large data always.
Sure. My question is, let's say if you have somehow you are in a platform with limited amount of resources and you have very little memory space.
Mm-hmm.
You query it.
Mm-hmm.
You query your silicon initialization or the OpenSFI,
Yeah.
and OpenSFI comes back with, hey, I need 10 megabytes, and you have only 500 KB. Would you crash?
That's the silicon vendor would have caught it, right? Like you are Intel.
That is what I'm trying to say. That you
Yes.
crash at this point, right? So you cannot do anything about it. So
Yeah, we can't do anything, but
what I'm trying to say is that without implementing an additional API to query the OpenSFI, you just give it the max you have. Let's say you've allocated space for stack, you've allocated for handle buffers, you allocated for everything else, right? So take all of that, and then whatever is left here, this is how much it is. Fill your output here. Now, again, if it is not sufficient, even if that is not sufficient, the API will come back and saying, "Hey, I cannot." In that possible space.
I'll phrase it like a different perspective, Raj, is in order to know what I am allocating, what is available, still is silicon dependent, correct?
Yeah, it is.
So in that case, yes, we can start with something. We can say, here is what I use. Hey, silicon, you know better. You go do whatever you want.
Right. So this
That's
is
the other way, right? Rather than saying, here is what you can go,
right.
we can say that, right? Hey, here is my stack range. Here is my code cache range, or here is my input range. Rest, you do whatever you want to do, right?
Yeah, but
That may
does
be a
silicon
simpler way rather than platform assuming something, silicon code returning something.
Yeah, but what is so? Do you want to put the burden on the silicon initialization to know what your host firmware is how the host firmware is allocating its resources? No, right? I mean, it has no business to know what the what host firmware resources are. All it needs to know is how much is being given to the OpenSFI, and the OpenSFI will come back saying, "Hey, this is not sufficient," or it'll come back with a success saying, "Here's your data, even though you already allocated, enormous amount of memory for me, but here's your data, and it fit within the space." And there was
The only input I have there, Raj, is how do I still need that info from silicon unless I make it a build time, right? How much cache is it available if there is no API?
how much cache is available.
Right, because there could be multiple SKUs we may support with the single binary. I have to either trim it to the low. It's not about like how do I say that, right? This Silicon X or Silicon X plus one or a variant of that has different sizes from a platform. If I want to support with a unified single binary, then I have to codify it in such a way that I only can use whatever is the common denominator, right? Even though the silicon may have more.
But so if you cannot fit it within the least common denominator,
Yeah.
well, what are you going to do? Let's say you have a barrage of SoCs or platform configuration, and the least common denominator is 1 kilobyte, happens to be 1 kilobyte, and I'm running on a bigger platform. What are we going to do? Are we going to crash?
Yeah. No, that's where the dynamic checking would help, right? So the choices we have there is we hard code at a outside platform layer that, hey, if it is this variant of CPU or processor, assume this is the max versus this. Or what we, at least my understanding, what Tim was asking is also is, why can't that be an API to tell like that resource availability so that we don't need to do anything customizing per platform?
No, we can do that. Don't get me wrong. I'm
No,
not
I understand, right? Because
technically
that is, we can solve it either way. And since we are talking across and for future, right? Anything we want to put the silicon burden on the platform is always going to be customizations needed or variants that will be there, right?
right. So what I'm trying to get to, I mean, what goes on in my mind, guys, and I need to align with you guys, because you guys are obviously in that space. I'm not, right? So hopefully I can align with you guys. So what goes on in my mind when I'm looking at these minimalistic approaches is that necessary, right? I'm a very frugal type of a person, right? Is that necessary, or is that discretionary, right? If it is discretionary, can we do with what is necessary, right? In my mind, necessary is just one API, right?
Fully aligned with that, no disagreement, Raj.
So
I was
that's the
doing the
bottom
same in
line.
my past life, so with FSP. So definitely I can echo, right, what you are
And I come
saying.
from the embedded world where the resources are very, very sparse. I mean, they are not they we don't have much resource. So I do tend to take a minimalistic approach, which some people would find it kind of odd, but coming from that side of the industry, I think we can. We need to. I need to understand you guys. I do understand from a host firmware perspective. UEFI, we do have ton of memory. Core boot, we do have ton of memory, right? But also to think about from an Intel perspective, yes, right at the beginning, what you were saying is that you guys even don't know what the configuration that you're going to be running on, right?
Yes. I mean,
So
it's generally true, except for like the AMDs or ARM case, right, where we have predefined, so we can assume things there. That may not be true for when we run in this, right, or other use cases. Again, we're not talking about embedded and all here, but same may apply there.
yeah, but in my mind, firmware has to be frugal, right? I mean, it has to be small. It has to be efficient in such a way that it executes in with less amount of resources, right? And
Yep, that's always the thing, right? Use minimal config resources, but do all the initialization and stay out of the way, right?
so I'm trying to understand the Intel side of things. So when before the UEFI gets control, right? Is it not executing some minimal code that establishes the cache as RAM?
Yes, it does initialize that, and it has to set up all the platform configurations like the DIM configurations or the population and any other things, right?
That is correct. So when it does that, it needs to know, okay, it has the firmware that initializes the cache as RAM. Once it initializes the cache as RAM, it establishes that, hey, this is how much amount of space I have for uh, for the libraries that get called by the UEFI or by the host firmware. And that max amount of space can be used and passed on to the caller to the callee as the output buffer, right? So you have to allocate some space for the input arguments, right? All your parameters and whatnot, right? So that you've already allocated that. You've filled that space with information. Now you have some space left. Whatever the space is left, you can send the pointer across to the library stating that, hey, fill your data in this output buffer.
Yeah.
And if it is not sufficient, then the library will come back and say, hey, I tried to fill it, but I could not fill it fully because there's no space. As simple as that, in my mind.
Fully aligned, right? And just to give context, right? That's exactly if I think in Intel FSP, the first API temperament is just doing that, right? Instead of platform doing it, the tempera-minute API will say that, hey, here is the cache RAM available total to you or whatever, right, setup. But that can be done outside. In core boot case, that API will not be used because it's something that generic, they can keep it consistent, right? So both ways are possible, Raj. And what we are looking is, should we have that as an option, or should we start minimalistic as, okay, you figure
I
out
would,
the
I would
cache
like to
RAM
challenge. Yeah,
and
I would like to. I would like to provide this as a challenge to all of us. Right? Make it optional. Make this initialization. So here's the thing. I can add another API called initialize OpenSFI library. Right? When you do that, it will return back saying, "Hey, this is how much memory I need," or "This is how much memory I have."
Yep. No, that's all. At least from my side, that will suffice. And we can think of if there is any other resources that would be good to report. But again, let's all should be absolutely needed,
Yeah.
right?
Okay.
But that could be changing, like for example, in case of caches RAM, that the memory map will change. It's if it's like the first question when firmware starts, who owns the memory? It's probably the OpenSFI would know like how much memory is available, right? So we have the initialize call. So we can define one of the first stages, like when platform firmware starts, it can make the first call to just essentially get platform information, get some handoff data. So it will describe how much memory available at this particular moment of time. And then for all the subsequent calls, we have this input output pointers, right? So it could be like a memory buffers and size, and we can have a simple, like if firmware has memory, it will pass the buffer. If it doesn't know how much memory is needed, or the firmware, I mean, the OpenSFI can always return like error code,
Tell you guys what. I mean, even better.
like I need more memory, and then return the amount of memory needed, something like that.
Even better, even better. Instead of me adding another API, okay, you just add the very first stage that you would add is init library, right? So you supply you provide init library as your stage ID, and based on that stage ID, the OpenSFI will return back to you, hey, this is what I have thus far in the output structure. Now, this output structure, of course, the memory, that much amount of memory should be available so that I can pass back the information to you. Do you guys agree with that?
But will the memory size change once you execute or finish the memory need stage?
It could, absolutely. And when it does, it will be provided back into the output buffer once again for that for that call. Thanks for joining, Jose, by the way. Appreciate it. I don't know what time you joined, but um, yeah, I mean, I think in addition, so instead of adding another call to that one call system, one API system, actually there are two because there's runtime, but for initialization, there is still just one API, right? With that one API, one of the stages would be init library. And the output structure that should be guaranteed by the host firmware. They should have minimal amount where we can pass the amount of memory or whatever, the cache as RAM, etc., right? That information can be passed into the output buffer. Is that a good middle ground without breaking the bank? Can I hit my gavel?
So yeah, I think that would be okay. Like, yeah, I think we need to evaluate, right? For me, instead of platform figuring it out, I'm always thinking about the case in here, Raj, is about if I make this call, whether it is Intel or AMD, if it gives me enough info, can I make choices so that I can have that initial layer pretty much straightforward, right? Which aligns with the OpenSFI.
That's right. Now let me also try to understand here, because there seems to be a chicken and an egg logic
Yep.
here, right? So before UEFI, before the first instruction of UEFI executes on an Intel platform, what executes? So between the x86 reset and the first instruction of UEFI, what is happening?
There is a lot that happens, right? The secure thing and also the early microcode loading and all this could happen. There is a different whole Intel side, right? I'll let Intel comment on it. But from host firmware, reset is the first thing we do, right? Up to that, we consider this as a hardware or like in the ARM or AMD tool, right? The reset vector is where we start executing, and there is a series of steps to check, and that is where we can deviate based on platforms, what to look for, what not to look for.
Okay. So but somebody here can comment on what happens between the x86 reset and the first instruction of UEFI for Intel and for AMD. And I think the maybe the BIOS vendors are in the position to answer that question. Srini, Tim?
Come again, your question one more time. You said from reset to...
From x86 reset to the first instruction of UEFI that gets executed. What is happening? And how much memory, and how does the memory get passed, or the stack, or whatever the amount of memory that you have, how does that information get passed to the UEFI or the host firmware?
Determination is done in the SEC phase. After reset, it finds out, runs some CPU ID instructions, finds out what is the size.
Depends. So from
No, sorry, I didn't quite catch that, Felix.
Yeah, I'm saying like it depends. Like from the UEFI/PI point of view, the PI core, which is the first architectural piece of firmware that runs, it receives a data structure as an argument that describes essentially the total available memory and portion of the memory used by the previous stage.
Yeah, so there is, so UEFI or the host firmware does have some memory to play around with that is guaranteed without any dynamic, without performing any query. It does have some minimum amount of memory for it to operate.
Felix, we should say it is being passed to it, right? The information from SEC phase to PA phase is being passed. So determination is done in the SEC phase.
Okay. Now that is with Intel. What about with AMD?
AMD, we get the information from the memory because all their memory directions already done. So they have their own area where the data, all the memory information is available.
But
just
actually,
like
Srini, it's the same, right? It's still passed to PI core as an argument. Just implementation is of that SEC phase that runs before PI core is very different, like for Intel and AMD case. But eventually, at the PI core, it's the same handoff interface.
Right.
Correct.
So
yeah.
So if that is the case here, then do we really need init library? Because we already have a sense of memory. So what are we talking about? Hey, querying how much memory do you have?
Since SFI is supposed to be the silicon reference code, that logic, I'm thinking, Giri, everybody's thinking that logic has to go inside the SFI, right? Otherwise, the small logic has to come out of your SFI and it has to be part of the host firmware. Right now, the SEC phase is doing that particular logic, right? So that I'm thinking that's what so far we've been talking. Hey, that logic also should go inside the SFI. Giri, I think, is that what you have been talking about?
Exactly. So for me, I mean, looking into that, right? Always, I believe like the right place to read a particular register or also give flexibility for the silicon vendor, right? If that register changes and all, it can be agnostic if we abstract it enough, right? I'm not saying everything need to be abstracted unless it is like architecturally published, right? Which platforms can do. So either one of these need to happen so that the platform code can still read this, right? If we say that, hey, here is a standard way, irrespective of how you get it, that here is the size, or you don't need to do this, or like this is the memory or cache as well. It doesn't matter, right? Can that be more a queryable rather than like a build time or even like outside of the silicon code that needs to be done? Because every time we do that, then somebody needs to be monitoring and restricts the silicon vendor to make the changes if they need to, but also adds overhead for the integrators like us or IFVs, right, to keep tracking and porting and managing this.
Mhm. So so I can definitely add initialize library stage as an option, right? It's an optional stage. But my challenge to you guys would be, can we do it without that? It would be a challenge for you guys. When you are implementing the val layer, can you do it without that? I will add it to the spec. I will put it as optional. And if we deem it absolutely necessary, the word optional will be gone in 0.5. Is that fair enough?
This can, yeah, I'm aligned on that, Raj, but I'm thinking other way, right? What goes into that API, what is needed from that API is where we'll scrutinize, right? More is, do I even need to add anything?
Do I need to add anything?
Like, do you like, as you said, right? Instead of API being optional, I'm thinking, do we need to add any values that need to be returned from that or expecting?
No, it's not. It's not API. I'm not adding API. I'm adding just the stage, an additional stage to the initialization silicon API. So the API will remain the same.
Yeah.
You will simply have a stage, an additional stage, the very first initial stage called initialization.
Yes, sorry, yes. What I meant is in that stage, right? Is there anything that needs to be done?
Um, well, it could, since it is optional, we may come back and say, hey, no operation or something to that effect as a status.
Yeah, it could be a simple return, right? If
Could be a
that's the
simple
case.
return. And but then what is, so what are you gonna, I mean, if there is no return, if there is no information coming out of that initialization library logic, then what the host firmware, it doesn't move any needle for the host firmware at this point in time, right?
So my take is there will be at least the size of memory in case of AMD or ARM, right? Or maybe range of that versus cache as RAM info in case of Intel is what at least I expect.
Okay.
But I'll let Srini, Tim, and others chat.
That information will need to go into the output buffer,
Yes.
right? Now, the output buffer, you have to have the space for the output buffer, correct? That is another assumption.
That will be okay. So you're talking about specifically that. Yes, for that, that should be very limited, right?
Very limited, but that has to be documented in 0.3, right? So, Giri, why don't we do this? Can you take a stab at putting that information in version 0.3? Maybe in the in where we are what section is this? Let me give me a second.
Yeah, I'll be out next week, Raj, so it depends on when you want this.
I wanted like this week, if you can.
This
Tell
week.
you what, tell you what, tell you what, I'll take my first stab at it. What
Yes, please. Yeah, definitely. I'll take a look before.
But I need you to bless it. I need everybody else to bless it as well, right? That this is a-okay, right? And it is, and I'm gonna be very open with you guys. That is going to be optional, and I will also document that if we cannot do away with that, for any reason, we will keep it for keep it at 0.5. But if we discover during our WAL implementation, if we discover that that is not necessary, that will go away. That stage will go away in 0.5. Or maybe it remains there as an optional. But see, the thing is, the moment you make it optional, people are going to use it. Everybody is going to use it, right? No matter what. I want things to be implemented if they need to be implemented, if they absolutely need to be implemented. That's the vision.
Yeah, I'm aligned with that, right? And I do like minimal, that we don't need it. But also the whole reason I'm speaking for this, Raj, is I don't have a clear picture that we may not need it for sure, right? Yes, we want to aim for it, like you said. But for me, it is too early to say
Fair
that we
point.
don't need it, is where
Fair point, Giri. Fair point.
Yeah.
Absolutely fair point. Okay. All right. So I'll go ahead and get that done sometimes this morning. I do have a busy day today, but I can find some time. Absolutely. Any other comment? By the way, Jose, thank you very much for your comments. And I was telling the team here right at the beginning. I don't think you joined at the time, but I was telling that your comments made me. It probed me to think a bit more, and I thought it was a great set of questions, and I ended up adding some clarifications in the document as well.
Yeah, thanks, Raj. And I was really making these comments so that we could to queue in some discussions in this call. Unfortunately, there was an internal meeting, so I couldn't attend the first 45 minutes of today's call. But maybe we can revisit this in 2 weeks' time. I was really trying to grok what the model is, and just trying to build my mental model of what we're trying to get at with this initiative, and trying to map it to ARM designs and ARM firmware. But it's certainly something that we can revisit.
Right. No, I mean, it really is appreciated, Jose. What I strongly believe from a documentation perspective that if somebody asks a question in a documentation, then I have not done my documentation right? So you're asking those questions probe me to add some clarification. If it further needs clarification, please do let me know. I'd be really appreciative of that.
Will do.
That way I can make the documentation really solid so that, by the time we release 0.3, there would be no questions asked, right?
Yep.
Okay, so feel free to ask follow-ups in the documentation, and then we can take it from there. Okay, let's not wait for the next 2 weeks. We can definitely review it again in next 2 weeks, but let's make use of the time, the 2 weeks time that we have over the documentation and right inside the documentation. Okay. And sorry, I took the entire hogged the entire meeting on OpenSFI. Felix, is there any way you can give me an update on? I know if people want to, if people can hang around for a little bit longer, that would be much appreciated. If not, feel free to drop. We will be recording this meeting anyways and transcribing it as well. So Felix, if you have the time and if you can give me an update on UPCI, I'd really appreciate it.
Yeah, essentially, as we discussed last time, yeah, I started I did some updates to the document actually just today in the morning, so probably people didn't have a chance to review, but I can give a preview. So mostly what I did, I maybe a little bit, I mean, the first sections are like introduction sections, which discuss the motivation and the requirements. So I made it a little bit more generic. The like original language was too coupled with the OpenSFI. I of course, you know, included SFI as one of the main use cases, but a little bit broadened the scope to cover other platform configuration scenarios. And then as far as the section that looks at the different potential formats, I also slightly expanded it to add a few other options, and I changed the SBOR language because, as we discussed, SBOR is kind of one of the potential formats, but not necessarily the silver bullet. Can you scroll to the end? So the most important is actually at the end, is conclusion sections. It's kind of this thing, yes. So essentially, this is like based on the analysis and the previous content. This is what we are coming with. This is like the conclusion. So first, we discussed we need like human representations and machine readable presentations, even though formats like JSON or XML can serve both purposes, but they are not practical for what we are trying to do. Hence, we need a separate like a human readable and machine readable representations. Essentially, source format, which is then compiled into a binary representation. Now, as we also discussed, essentially, at least for some use cases, we definitely need binary buffers, so there is no getting out of it. At the same time, so binary representation, raw binary buffers should be at least one of the supported formats. But then there are use cases, as we discussed, that simply don't work with the raw binary buffers. For example, constructions of the information to align with other industry standards, such as Redfish attribute registry or the MHS, this self-described JSON format. So, which means there may be requirements for multiple binary representations. And of course, the key is, because if we have like multiple source representations, multiple binary representations, then we are kind of not achieving our goal, because we still have the same information is represented in multiple formats, and manual conversion required. That's something that we want to avoid. So ideally, it should be single source representation that can be like compiled into multiple binary representations. Now, as far as another option, like we probably didn't spend enough time. If you remember, during face-to-face, many people were asking, like, why not just use device 3? And then, of course, the like SLAML, those are the two formats that essentially are specifically designed to represent platform configuration. So why just don't we use those? Of course, the answer is those formats are mostly, actually, both of those were designed to convey information from the of our complexity threshold. Maybe, you know, it requires a parser to handle it. And then even though I mean, there are some format limitations, but then also, no matter what, we cannot use those like device 3 as is. We would need to extend it. But then when it comes to extensibility, even though like device 3 compiler is designed like as a foundation for like some derivative languages, so I feel like that maintenance effort will be significant, which at the same time, we don't want to design our own language from scratch, which essentially leave us with like a structured format languages such as like XML JSON or YAML. So those are typically very good for, those are just abstract ways to describe an arbitrary data structure, which means it should be, and there is an API to build, I mean, for virtual every programming language to build on top of them. So, and I am saying and feel like between those three options, JSON, YAML, XML, YAML is kind of a middle ground in terms of like compactness versus like human friendliness. So this is actually as far as I updated. So my next steps would be to, as far as the binary, we discussed that maybe for the OpenSFI, we will advocate usage of raw binary buffers, but there is still, it's a multiple data structures. So we need to organize them, you know, in some way. So I was planning to propose to use that firmware handoff specification, I mean, created by ARM as a, as that packaging format. So that's kind of the first target. And then maybe we need to create like a separate document to enumerate certain use cases. Like we can look at certain aspects, and first we can do it like a case study, but then eventually it will evolve into the data structure format definitions, as we discussed. That kind of, in addition to defining an abstract infrastructure, we would like to define a specific configuration formats. And a little bit like lower priority, but also important activity, probably this is like towards 4.5, is to come up, like I'm saying, we can build our source definition on top of like whatever, YAML or JSON, but that needs to be defined. I need to come up with some proposal.
So, so we haven't concluded then.
So no. So you see, as far as the OpenSFI, the binary format, we concluded we'll use the raw buffers.
With the raw buffers, but
Yes.
but the raw buffers are not interpretable. The requirement was that we have interpretable.
Yeah. So what? Okay. So let's see. So for example, if you have a like handoff blocks or whatever, ARM handoff data structure, if you list data structures with a basic size and a tag, then you can iterate, you can find your own instance, and you know the size of the instance. But then within the instance, it's a black box. You are right. But then if you look at the, for example, CBOR interpretation, in a way, you have the same problem, because you can decompose CBOR stream of bytes into integers, floats, and strings, but you still don't know what to do with them. So that kind of schema information is missing. So what I was planning to do, as far as that source representation, we will have a schema, and then there will be a way to package that schema into a binary. And depending on the use case, we can have, for example, for some like extremely constrained environments, you know, they may be just fine with the raw buffers because they just need to program whatever 5 registers and no advanced manageability and nothing else is required. But then when the use cases require a more advanced infrastructure, there will be an option to package that raw buffer with the schema, and then the schema can be used to interpret the raw buffer.
Right, but wasn't there, you know, one of the requirement was that, hey, we want to be able to, we don't want to break the APIs because we went ahead with the certain version. We went ahead and changed the structure, right? Or added more members to it, or deleted some of the structure members. So that would break forward and backward compatibility. So that's what that is the reason why we wanted to go with an interpretable binary. And within, we also agreed that within the OpenSFI, we will have capabilities to convert from interpretable binary to raw binary, or raw binary back to interpretable binary.
Yes. So
For the producers and consumers, of course.
yeah. So we need. You're right. We need a way to address backward compatibility. So what we have with the with the firmware handoff, essentially the way it's defined, you can add new fields at the end of the buffer, but you cannot change existing definitions. If you add, the only way to change existing definition is by defining a new type. So the binary buffer is a collection of tag data structures. So, and the tag defines the format. So format can be extended by increasing size. So essentially your size fields provides you the tag and size together defines the backward compatibility model. It's not like the main advantage is simplicity. As far as the sometimes people may want to shuffle fields within the data structure, but I'm not sure
that is very easily done here, because you are describing. So if you're describing your data, then where that data lives, whether it is in the top of the structure or the bottom of the structure, that doesn't matter at all. As long as you can extract it, as long as you have the APIs to extract that, search and extract it.
Yes, but okay. So if you want to go with that approach, then you have to use, for example, in case of CBOR, you have to use maps, right? Name value pairs. That's the only way to get to be independent from the ordering. But then you depend, instead of, in case of raw buffer, you depend on particular offset, right? You need to know that, okay, my data is at offset 8. I need 2 bytes at offset 8 from the beginning of the buffer, and that's a limitation. But in case of CBOR, instead, you need to know a key you depend on. My data is at key blah, blah, blah. And then if we use string keys, size explodes. If we use integer keys, then it's almost the same. Like rather than depending on arbitrary string offset, we are dependent on arbitrary integer keys, because integer keys is indirectly an ordering as well, right?
And I'd add to all of this that no one likes looking at or inspecting hex dumps. And so no one's really advocating for this. And I think that what Felix is suggesting is, rather than having a single level of a data structure, we have a multiple, in this case, 2-level data structure. One which is just tagging different binaries. One of those binaries can be a CBOR encoded binary, which has all the richness and flexibility that we are really looking for. And ideally, all firmwares would just consume the CBOR encoded data, because that's so much better in many regards, right? But again, some other firmwares don't have that level of capabilities, and it still makes sense to allow these firmwares to be able to traverse a list of binaries, so that it can find the raw binary that it understands and it wants to consume, or it needs to consume.
Right.
Yeah. So that makes sense, but one challenge is that sometimes the same piece of information has multiple consumers, and some of them may be like may only afford to work with the raw buffers, but others run later in the firmware stack and can afford, like richer formats such as CBOR. But we want to avoid, right, having copies of the same information in multiple formats.
That it's definitely a good observation, and yeah, definitely information shouldn't be replicated. If we ever need to go there, then it's a very bad place to be in.
So I agree. We can, we can have cleanly like different types of information can be represented in different formats, but at the same time, to solve this problem of when the same information needs to be accessed in different way, I thought that maybe we can have like a extensible, like you can have your raw buffer optionally complemented by the schema information that can be used to decipher it. Then the like early stage firmware can completely ignore the schema part, and then a more sophisticated firmware can leverage it to do some more advanced process, or maybe even
So how do we conclude, guys, here?
So I think this is good enough for now, because the real way to resolve this is to do something practical. So that's why I'm saying we need to start playing with the specific use cases, and then we'll see, oh, for this use case, raw buffer is a problem, or maybe the other way around, CBOR is a problem. So as far as I think we went as far as we can generically, that we are saying, okay, we are willing to support like multiple options, but then let's look at the specific
specifically for OpenSFI.
Yeah.
I want to bottom out on it.
Yes, but for the OpenSFI, currently your input and outputs are void pointers, right? So essentially, the exercise is to define those formats.
Right. Yeah, but we do have to conclude.
So again, if we start, one logical way to start is from the reset vector moving towards S. So I think at least the early calls, those are the examples when like the CBOR would be too complicated, right?
Well, why do you think it would be complicated?
I mean, because we may be running from temporary RAM, the memory constraint environment. Also, you see in your
I mean that
in the original in the original.
Yeah, so this would be in the I mean, it depends on how much data you could see. Here's the thing. I mean, it's either you provide the, there are some requirements. The requirements are backward compatibility and so on and so forth.
Yeah.
Because of that, we need to resort to interpretable data format. Now, granted that, if you have that requirement, then you are conscientiously accepting that your data is going to bloat. Right now that you've agreed that data is going to bloat, now you want to figure out, hey, what is the minimal bloat that what scheme will give me the minimal bloat, right? Would that be ASL, AML? Would that be XML? Would that be YAML? Would that be JSON? Would that be CBOR? Right? The minimal bloat, in my mind, would be CBOR. Right? Now, if we cannot live with the CBOR, then we need to scratch off that requirement of backward compatibility. Then we need to be very cognizant of the fact, we need to be very attentive with our structures at all times. That puts a burden on the reviewers.
It does put a burden on the reviewers, but you can also adopt patterns where you're not necessarily extending indefinitely a given raw data structure definition. At some point in time, you can create a new data structure definition that complements the previous one as you're appending new fields to address some use cases. So
Yeah,
I'd argue that the bloat can be somewhat mitigated. There's always going to be some manner of bloat there, but also there's an underlying assumption which may or may not hold in reality, that these data structures that we're talking about, it may be that we don't have many compelling any obvious need, or at least a frequent need, to go and extend them in any way. And your concern of having bloat building up over time is that we will need to frequently fix any shortcomings of the data structure definitions.
Jose, from your perspective,
did we lose?
You're breaking up from my side.
Yeah, I think
yes, Riyad.
it's in throughout our conversation, you have been breaking up.
Okay, yeah, I think I'm having some network issues, even though I'm on corporate Wi-Fi. But Jose, I want to ask, from your perspective, will CBOR work for the OpenSFI, specifically for that early initialization stages?
Well, in the previous call, we were discussing having a narrow scope, and so the CBOR encoded data structure would be passed across the OpenSFI interface, and I think that that's fine, with the notion there that if platforms need to, on the platform side of the OpenSFI layer, you could have a mechanism to translate that CBOR encoded data into raw binaries if you need to. I think that that's entirely fine.
Yes, and that's kind of aligns with my paradigm, but there are two challenges that we have to solve. First, kind of constructional. I think, Raj, in your spec, you are the CBOR parser is part of the chipset firmware, which, that's a generic code. It's probably not the best.
No. It is not part of the chipset firmware. It's not part of the silicon initialization. It is part of the OpenSFI, which needs to be standardized, right?
So in practice, it's going to be part of the platform firmware, right? It's not going to be a portion that is delivered by like AMD or Intel.
Oh, no. It would be part of the OpenSFI. So OpenSFI, so when you take, so there would be layers that are common across multiple vendors, right? This layer that we are talking about, the conversion from CBOR to pure raw binary, et cetera, et cetera. So that could be a common layer that would need to be supported by all the vendors.
Okay, so from the spec point of view, I understand it's part of OpenSFI, but from the implementation point of view, for example, this is going to be part of, like, for example, EDK2, not part of the AMD OpenSeal, correct?
No, it won't be part of the AMD OpenSeal. See, you have to remember, there seems to be some incoherency here. When I talk about OpenSFI, right, it's a layer on top of OpenSeal. Okay, now that layer is a library as well. It's a library. It's a set of library functions, right? Today, it's a set of two library calls exposed to the host firmware. One is initialize silicon. The other one is silicon runtime ops, or execute silicon runtime ops, right? Now,
so you're saying this library depends on Cibor library, right?
Yes.
Okay, that maybe we
And
will see, but at least now I
guys,
understand.
this is a question I had when I was trying to understand the whole model and how this maps to ARM. I'm not very familiar, and I'll ask for forgiveness right away. I'm not very familiar with the Intel and AMD model, but I kind of have all that I read kind of suggests that the OpenCL interface is implemented at a very early stage in the host in the host AP boot process, right?
That is right.
And I was really going to ask Felix and Srini, because I know you guys are also familiar with ARM platforms. And in the ARM case, where do you see the open SFI interface being implemented? Is it something like in the non-secure firmware side, after you possibly executed a bunch of stuff already in the host AP?
Yeah, it is. Yes. Yeah, it is DL33. Yeah.
Okay.
Yes, it is DL33. I understand ARM as well. Sorry, no, I was just kidding. So Jose, it should be. I mean, I'm hoping that it is as simple as that. But what's in your mind? I do want to make sure that, as we mature this specification, and when we get to ARM, right, we'd have a smooth transition for ARM. Right? I don't want to get into a point where, oh snap, had we looked deeper into it, we would have recognized that XYZ step that we took is not favorable to ARM. Right? So I don't want to make those mistakes. So I want to avoid the mistakes right at the beginning.
And we should keep those questions in mind as we progress. And by the way, I would also say right away that I don't have a view of how the different ARM vendors structure their firmware. And that landscape may be quite varied, especially the closer you are to early boot stages.
I see.
But if I keep in mind the canonical view of ARM firmware, once we're in DL33, then we're pretty much in platform agnostic part of firmware. And quite a lot of the platform initialization phases have already been completed. So some of the stages, and now going back to the OpenSFI, some of the stages that we have there, when you call initialize silicon with some of these stages, most of them are just going to be no ops. Right? And maybe that's fine. And this means that there won't be any impedance mismatch when we extend this to ARM platforms.
But then it needs to bring some value to the platform vendors as well, right? I mean, if you guys are not, if there is nothing that is, if most of it is coming back as, hey, unsupported, then
not unsupported, but success. But it doesn't really do anything, right?
But it doesn't do. Yeah, I mean, that's what I meant.
See, it may not perform actual hardware interaction, but it can be just a mechanism to get the data or to get the platform policies.
Right.
Yeah, I mean, just like how we do in AMD as well, Jose. And this is public information where a lot of security gets done before the x86 comes out of reset, the main x86 core. The memory gets initialized, the internal fabrics, they get initialized, the SOC fabric, all of that gets initialized before x86 comes out of reset, right? Now, once the x86 comes out of reset, yes, there are stages for memory initialization. Yes, there are stages for fabric initialization. But those stages in the x86 that are done, that are executed by the x86 firmware, which is what OpenCL is, those stages are simply collection of the data that was generated by the embedded firmware, right? Then passed up. right?
So that's a very good description, and thank you. Then this changes my perception of what we're trying to get at here, which at least for the AMD implementation is really an information retrieval mechanism by platform agnostic firmware, right? It's the way that the platform agnostic firmware discovers the aspects of the platform that it's running on.
That is correct. So the question is, how does the ARM world in comparison to what I just described for the AMD world, which by the way is somewhat different from Intel. Again, Intel, there's a lot of stuff. There is some stuff done by the security processor, but most everything else is done by the x86 silicon initialization firmware.
Yeah. So and again, focusing on particular implementations in the ARM world, the idea is after some privileged firmware finishes up executing, it just dumps all the information and all the hardware description to UEFI, this thing that we keep calling BL33. And so once that's done, UEFI has all the information about the platform, and it doesn't need to access that information via this interface now.
Okay. So your actual silicon initialization is done by is that done by an embedded microcontroller or by the host microcontroller?
And again, if we're going to this very early initialization phases, I assume that different platforms may have very different decisions, and ARM being an IP vendor, because we don't really have concrete platforms, I don't really know how that happens in real platforms, right? Okay. I can hypothesize that some platforms do platform initialization in microcontrollers, so not on the host AP.
Now, when you say platform initialization, do you mean to say the SOC initialization or platform?
So DRAM training, IO subsystem initialization, that can be done on microcontrollers other than the hosts.
Got it. Okay, that is super clear. So that's exactly the same way that we do at AMD then.
Yeah.
Okay. Okay, so I think ARM and AMD are somewhat on an equal footing, you know, from a general boot perspective. But you know, there shouldn't be any, in my mind, there shouldn't be any gross you know, mismatch or incompatibility with the APIs between AMD, ARM, and Intel. So those initializations or those silicon initialization stages that I populated there, not sure if you've looked at the my comments back to you, but those are for illustration purposes only. They are not fixed.
Yeah, Raj, I'll just add one more comment here. Intel is at one end, ARM is at another end, and AMD is little bit further from Intel. That's where, as part of the silicon initialization and data passing is concerned. Okay, so
Intel meaning Intel in the middle, and
no,
ARM.
Intel is at one extreme where you have to do more, and then little bit less for AMD and lot less for ARM. So that is where the spectrum lies. So there are very few on mostly the data layer for them. Just return the data. Not much of silicon specific calls happening in the UEFI time frame.
Yeah.
But it's not.
Technically, that is how it should happen. And technically, even OpenSil shouldn't have to do any silicon initialization at all. But the reason for it, you know, there are various reasons why it is doing some initialization also in the x86, but there's no reason why that cannot be pushed further down into the embedded firmwares. But that's
what is the current implementation?
The current implementation is it is doing some initialization in the OpenSil as well.
Some is a word I don't know. Okay, fine. That's a degree of things. Okay.
Like, for example, the data fabric initialization or the PCI, right? The fabric initialization and all this stuff. That is done in a lot of it is done in the embedded firmwares, a ton of it. And comparatively, it is only some that is being done in the x86, which over time, we will push it back down into the embedded space as well, if we can, right? If there is a technical reason, which I don't know of any, but if there is a technical reason why it has to be done in the x86 firmware, then it will remain there. But that is that it's a staged or a
Yeah, but we are not there yet. Okay, but we are
not
not there yet. Okay, but just by knowing from different ARM, just like what you are saying, we have worked multiple ARM where we have seen very minimal silicon initialization happens in UFA timeframe for ARM. Right? Generally, it is just the pure data. Like maybe Jose can go and look at it, multiple implementation, whether they have access or not, I don't know. But yeah, open source is still available. They can go and look at it, and then they can come back and see what fits in what layer that we are open SFI layers that have been defined. They can add the code, make it for ARM ecosystem. They can define and say, hey, this is where you return the ACP tables. This is where you build the SM bias table. This is how you return. That is something infrastructure ARM can work and give it as a standard implementation for all other firm silicon vendors.
Right. Okay. Yeah. I agree. Agree with you 100%.
Yeah. Another important aspect, we before we jump into discussing those details, Sam mentioned like we are fine as long as we can do automated translation from, for example, CBOR to a raw data buffer. So that's
one more question, Felix. Just a minute. I did not understand when you say open SFI. Raj, so we are talking about is what than another layer on top of OpenCell. You said another layer on top of FSP is OpenSci-Fi. Is this layer being open source somewhere? It will be another GitHub, or you will carry it along with it, and Intel will carry it along with their own FSP, so Open SFI interface itself.
So that tells me, Srini, that you haven't reviewed the 0.3 spec.
Look no, not yet. Not yet.
Look at the val layer. So val layer is basically your vendor abstraction layer. It's a library in my mind, and library of 2 API functions, right? And those API functions will be as they are spec'd in the OpenSFI specification will be implemented. The val library is our implementation, in Intel's implementation, AMD's implementation, ARM's implementation, right? So, but they will be adhering to the specification, right? But the implementation of how those APIs get translated, get abstracted into OpenSFI calls, right? That will be implemented by us. How they get translated to OpenSF to Intel FSP will be done by Intel. How that gets translated or abstracted to ARM APIs or ARM initialization, that is ARM's. That would be ARM's implementation. So the vendors would be implementing. OCP will be ensuring that all these vendors are adhering to the specification. That will
okay. Spec alone it will come out. Spec alone will come out of this. Okay, that's understood. But actual implementation I'm talking about is so AMD will release it along with OpenCell, correct? On top of it.
That is correct.
And Intel will do it. Yeah, along with the FSP, it will be there along with them. Okay.
And when folks like Google and Microsoft, when they design their platforms, they would have 3 platforms, right? Same platform netlist, but different silicon, right? One for AMD, one for Intel, one for ARM-based SoC. And when they produce, when they produce the IFFI or integrated firmware image for platform A, B, and C, it'll be seamless integration. They won't have to do a lot of, they won't have to do, ideally, any changes in the host firmware. Today, they have to make a lot of changes in the host firmware. And once they've done it, I mean, it takes many resources to support that entire stack for platform A. Same, many resources for platform B and for platform C, right?
Okay, thank you. Thank you. Yeah,
Now
thanks.
all of that will go away with this layer.
Yeah, go ahead, Felix. You are saying something.
Yeah, I'm saying that when we're talking about CBOR, just it doesn't automatically, I mean, gives us benefits unless we define it in the data structure in a certain way. Like if, like I think Ranj, you mentioned that one of the important benefits is no dependency on the ordering that will provide backward compatibility or forward compatibility. So, which means we have to use the mapping. But if we do use the mapping, I mean, as a base data, I mean, data type. But if you do use the mapping, that solution is always a problem because our data structure has no dependence on the order, but it means that we cannot convert it to a binary buffer because to construct a binary buffer, we do need to know the strict ordering of the data fields. So point being is that what I say is like requested, we are fine as long as we can do back and forth. It's not there by default. Maybe we can instrument CBOR with some redundant data that you know introduce the ordering, but then again we are back to the same problem that we are no longer like immune to reordering of the fields in the future versions of the data structure.
Yeah, but here's when you have the fields changed, right? When the fields change, then when we convert these libraries that we the internal APIs that allow you to convert from CBOR to binary, binary to CBOR, they will be aware of your binary structure. You see my point?
But then
so when I change my structure, right? When I change my structure, I will need to make amends to the conversion APIs as well.
Yeah, but that's a problem because, see, the configuration may be decoupled from the firmware. For example, people may want to do firmware update and retain the configuration data. So the new code may be dealing with the old configuration or the other way around. Like maybe we are provisioning some configuration updates in the new format and then it deals with the old firmware. So what I'm trying to say, we can always solve backward compatibility problem, but by tweaking the C code. But I thought what we are trying to do here is to avoid tweaking of the C code.
Mm-hmm. Let me put together something for you. I mean, maybe in some sort of a diagram or something like that. Give me till next week, till the next meeting, and I'll come back to you with the response to that. Okay. Right. Okay. And sorry, Jose, I didn't mean to cut you off, but go ahead.
I was just trying to reason through this, and I was asking myself whether we need back and forth translation of CBOR to raw data, or whether for the ARM case and in my current simplistic view of how this would be realized there, maybe we just need to translate or traduce the raw binary into CBOR, so single direction. But what this really So the
Yes.
val there would be a CBOR, would just be a logic that constructs CBOR. I don't know
Yes.
how involved this is
Yeah,
in
and
the
that
end.
actually that may be in line with my line of thinking, because as we progress through firmware stack, it is more beneficial to use more and more sophisticated formats. Like eventually, for example, we need to build like an AML and maybe device tree enough that we can do some of those things by abstract builders. Like for example, like a piece of code takes input format and output format and does conversion with really no in my mind that will be acceptable to create CBOR from raw buffer. No, it is possible to, if you have a combination of raw buffer and schema, then you can definitely construct the CBOR. Like, or you can replace the schema with, as Raj said, with the a priori knowledge of the buffer format. But that's something we are trying to avoid, because you know, whenever you introduce new format, you have to go and change that piece of code. So what my idea was is to yes, to have a like raw buffer complemented by the schema, and then that will allow you to do conversion into any CBOR or any other more sophisticated format.
Yeah, the raw buffer with the schema on top, where I assume the schema is really an index into the raw buffer. I think that that's quite a powerful notion.
Yep.
There might be some use cases, and maybe I didn't fully understand the idea there or the intent. But if we had some firmware that then adds some entry or some new structure into the current raw binary data structure, then you would also need to update the CBOR index, which may be tricky.
For example, to construct CBOR or even JSON for that matter, representation of the raw buffer, what you need to essentially offset and size of each field, right?
Exactly. You'd need name, offset from the start of the data structure, and the size of the field. Yes, and probably the type, like the encoding that's used.
Yes, and then, for example, if you want to go further and construct some, you know, human readable representation, maybe your setup screen, then in addition to that, you may also need like a help text or maybe a list of supported options, something like that.
Yes.
So that, you know, you can have a layered, you can go as sophisticated as you want or keep it as minimalistic as you want. Like
yes.
a scale.
Here's the document. I don't think Felix, have you gotten a chance to look at this?
Yes, I look.
Case for
and what I'm saying, this is a very good document, but it's incomplete in a sense that you're saying, okay, that is why CBOR and this is the end. But what I'm trying to say, CBOR is not the end, and if you keep continue into that rabbit hole, you will find some challenges with the CBOR. Like for example, there is no schema again. The CBOR can be decompositioned into primitive types, but there is no way to there is no standard like schema definition. For example, you can say, okay, this int value is like whatever CPU frequency, and that int value is a number of sockets.
Actually, not that anyone wants to really do it, and whenever we do it, it's because we're really forced to, and there's no alternative. But if you look at binary dump of a CBOR, can you make sense of any of it, or is it very compressed?
Yes. No. It's uncompressed, and you can like decomposition it into native CBOR data types, which are integer, float, I think Unicode quote string and byte string, something like that.
Okay.
And also mapping and list. So it's like you can do it like with a pen and paper. It's like tedious, but you can.
Okay.
So in that way, it's a little bit better than raw buffer when you don't you can't do anything. But still, as I said, once you end up with those primitive types, you still don't know their semantics.
Right. And by the way, I have a meeting that I'm hosting in the top of the hour for which
Yes.
I haven't prepared yet. So I need to drop. But feel free to have this conversation. But
Okay.
Jose, do me a favor if you could take a look at this document. I just shared it with you, and I can see if I can copy the link here and post it here.
We'll do, but by the way, Raj, I completely understand all the argumentation for self-describing, human readable, human parsable
Right.
data. So I'm fully bought into it.
Mhm. Yeah, there's a case, for OpenSFI, right? So that's this document. It talks about, there's some examples also.
Yeah.
And maybe like from my side, one closing statement. I also, Raj, yes, this is very persuasive. Just when I started having some questions is if you accept that you agree with that and then you start working on the next step, that's where I'm all those arguments that I bring in today, they're coming there. So if also during those 2 weeks you can think from that perspective, what is the next spec? Okay, let us start defining those CBOR data structures, and then maybe you will also see some of those challenges that I'm trying to describe.
Right. Okay. All right. Sounds good. So it was also to unify the structure layouts as well for the vendors as well. So, I mean, it's not just it would be a different structures. I mean, I was trying to think that if what if we have the same kind of structure as well. One we it would be very challenging for the platform firmwares that the output structures or the input arguments or some stuff like that, uh, they are extremely different or overly different between the vendors, right? So just a wild thought, but view it from that angle as well. So I need to go ahead and drop. But thank you everybody for your time. Really appreciate it, and great discussion almost toward the end for UPCI as well. So I think we did make some pretty good progress in our understanding and alignment between amongst the team members. So thank you very much. Hope to see you again and talk to you guys again next week. Bye for now.
Thanks.
Thank you.